Hi everyone, we are Team ASHTOJ and this is our solution for the Smart India Hackathon problem statement number 25161, mitigating national security risks proposed by large language models in AI-driven malign information operations. Our project is called TattvaDrishti. It is an AI-powered platform designed to detect, analyze and mitigate malicious AI-generated narratives in real time. Large language models such as GPT, Claude, or Gemini are capable of creating extremely realistic and contextually fluent text. Unfortunately, this power can be misused very badly for disinformation, phishing, and propaganda campaigns. Our platform acts as a digital defense layer that analyzes any text of piece or post and tells us whether was likely generated via an artificial intelligence system, and more importantly, whether it poses a malign or national security risk. So let us show you a bit brief about what we have done. Our system has been built as a modular fast API backend which has been designed to be able to run on various different kinds of servers. It has different modes which helps it decide what kind of a platform is it being run on. It has an intake platform which takes an input via it takes any suspicious text via API intake endpoint with the metadata such as source and details of the input. Then it can take the region and other information about the text that is being taken. Then is the core of our entire system. Our entire system has a detection pipeline. Our detection pipeline runs a variety of different systems to reliably and accurately determine the malicious intent of a text. First of all, our primary detection system is using the GPT OSS 20 billion model via Olama. We run our entire text. We let Olama decide what kind of a score would it like to give based on the intent of the text, the kind of content it has. Other than that, Hugging Face's Roberta acts as a secondary model giving a numeric probability of whether this content was AI generated. It generically tests if the content is an AI text or not, whereas the Olama model more specifically checks if it is malicious and does it contain fraud information. Whereas this entire thing also is cross-verified by other normal text standard checks which check the content, the length and the other information about the text. This helps us get overall information about the text. Other than that, I'm using network X to create a graph of the text, of the flow of the text. This graph also helps to create another thread graph. It helps to link similar posts or actors using net graph analysis to reveal coordinated disinformation networks. This is generated based on the storage of every request the user has ever sent. I'm using an SQLite database which stores every request that has come, from where it has come, what was the score, what was the kind of text that was. This data is then used to generate the entire net graph. These are all the cases which also monitor everything. Every user input, the kind of text that was sent in, the kind of similarity between texts, the similar type of attack parameters which are being reused again and again. This is a dashboard we have created to demonstrate the capabilities of our API. This is a simple dashboard which shows the entire statistics that the API generates. And this is an excerpt from Mr. R.K. Narayan's Wikipedia page. This is authentic text from a very leading Indian author. Let us see what the API returns when we try to analyze it. And as we predicted, this text is safe. It has a very low composite score and an even lower Olama risk, qualitative risk. The linguistic confidence is high as this is genuine text from a very structured source. Linguistic confidence would be lower if the text is unstructured or has a mixture of different kind of writing styles. Whereas this is a scam text, a fraud text specifically designed to create misinformation and spread propaganda against the country. And now let's see how does it perform in our API. And as we predicted, this is detected as a high risk text. This has given a Olama qualitative risk score of over 90%, whereas the linguistic confidence even here is above 75%. A lot of other competitive platforms use linguistic confidence as the only measure of testing. This leads to very structured AI generated text to pass security concerns, whereas they are still extremely risky. This also gives a lot of other stylometric anomalies. It gives the average token length, type token ratio, hapax ratio, sentence length variable variance, burstiness, function word ratio, and uppercase ratio. All of these together contribute to the composite score. The composite score takes a variety of different inputs, and this is the triggered heuristics. This gives a very little summary of what the entire text is and how is it and why is it not safe or safe. The other thing are the provenance checks. These check is the text watermarks fingerprinted? Does it have a digital signature? These things help identify government or official information. And next is the graph intelligence snapshot. This helps identify the nodes, the edges, and the communities, which helps to identify similar text coming from different sources. The next thing is the submitted payload. This is the entire text that was sent. This helps to know what the text was. Because this dashboard can be later on used to track multiple texts. So this thing just stores the entire text, as I said, in an SQLite dashboard. The other thing is generating sharing package. This wraps up the entire analysis of the API and signs it into a package and can be directly disseminated to the partners directly through the API. This can be sent to your any destination. You write the justification, you include the metadata, and you can build a package. This would give you an entire JSON metadata and the entire package of this particular text. So this is a small demonstration of what we have created.